We'll start off in chapter 2 with graphing different equations. First off, a straight line. Anytime you have an equation in which it has x and y, and there are no exponents in the x or y variables, then you're going to get a straight line. In fact, if you have just x or just y, you will get a straight line. If you have both, you'll get diagonal straight lines. We can look at the points that make up that straight line as solutions to that equation. In other words, here, if we have x is 2 and y is 3, so 5 times 2, that's 10. 10 minus 2 times 3, that's 6. 10 minus 6, that is 4. It is a point that solves that equation. And in fact, you'll find that all of these points solve this equation. They all give us 4. And the set of those points will be this straight line right here. Now, what you see is an example of what's called a T-chart. A T-chart is where I take the equation, pick an x, find the y, and then that gives me an ordered pair of points in which the first number is always x, the second number is always a y. But an ordered pair, it's kind of like if you want somebody to come pick you up, you don't say, just pick me up on Knees or Herndon or something. You have to give them 2 streets, an intersection where to go. Well, this is like one street and another street, and this is the intersection between them. And in fact, let's take a look at a graph in particular. So the horizontal are the x values, the vertical are the y values. When we go to the right, positive x, to the left, negative x, go up, positive right, positive y, and go down, negative y. We can divide up the graph into what are called 4 quadrants. So here, both x and y values are positive. Over here in quadrant 2, the x's are negative, but the y's are positive. Quadrant 3, both x and y are negative. And here in quadrant 4, the x is positive, but the y is negative. At the middle, where the x and y axes intersect, is the origin. Here are the points A, B, C, D, and you can see them here. A, B, C, D, all lying on that straight line. Now, if it's a quadratic, in other words, there is a squared term for one of the variables, then you get what is called a parabola. In this case, a U-shaped figure. If we have a negative sign in front of the x variable, so in this case it would be in front of the parenthesis, then we would invert our U-shaped, turn it upside down so that it would open down instead of open up. One of the nice things about a T-chart is it can give us a graph of any kind of function. And so in this case here, we've got these various x's. So we've just gone down from negative 10 down to negative 2. And then you can see how the y's go. One of the things to note about a parabola is it has symmetry. So, for instance, here at the bottom, negative 6, negative 7, bottom of the graph right there, that is called the vertex. And then on either side of that, notice that the y values match. So 1 up and 1 down, they match. 2 up and 2 down, 3 up and 3 down in terms of the x values. And here you can find out how to, we got all of those values. The letters are as T down to Z. You can see here we go. in that U-shaped figure. If it is a square root type function, such as this, again, we can make a t-chart, but it is easier in terms of graphing. In other words, we'd like to have whole numbers so that they're going to be on lines. It is easier to graph if what we do is try to pick x values inside the square root. That will give us squares. So when we take a square root, we have a whole number. So note, here I started with 2. 2 minus 2, that's 0. Square root of 0 is still 0. So y value is negative 9. Then I went to 3, because 3 minus 2, 1. Square root of 1 is 1. 1 subtract 9 gives us a negative 8. Then I jumped to 6, because 6 minus 2 is 4. That's the next square. After that, I jumped to 11, because 11 subtract 2 is 9. Again, I can take the square root of 9. In general, square root type functions will have this kind of graph. It's kind of like half of a parabola on its side. Now, the chapter ends. Let me zoom out just a little bit so see more easily. The chapter ends with two formula. One is the distance formula between 2 points, and the other is the midpoint formula. So a point that's halfway between those 2 points. And basically, when we have 2 points, for example, in our diagram, 0.29 and 0.81, and we want to find the distance between them. First number is always labeled x, the second number is labeled y, so we could say this is x1 for the first x and y1 for the first y, and then over here x2 and y2. It really doesn't matter which one you want to call the ones and which one you want to call the twos. Usually I just do it as you're moving left to right, kind of the way you read, but you can do it any way you want. So I could have called these ones as 2. And so by the formula, x2 minus x1, and so note the 8, subtract the 2, y2 minus y1, so here's the y2 minus the y1. Now, they get squared, so even though 1 minus 9 is negative 8, negative 8 squared is still a positive 64. Add the 2, square root, and we get the distance between those two is 10. If we want to find the midpoint of those, notice that it's x1 plus x2 added together and then divide by 2. So basically the average of the 2 x values and the average of the 2 y values to give us the point that is halfway between. And in this case, we're labeling it an M for the midpoint. So for right now, all we're trying to do is for various types of functions, make their graphs, make t-charts so that we can see where the points lie and then connect the dots. So let's look at some examples. So we're first going to look at graphing these points, negative 5, 6, 7, 4, and 2, 11, and then we're going to graph a straight line on this first graph. Okay, so again, this is always the x, this is the y. So if I want negative 5, 6, I'm going to come over here to negative 5, then go up to 6, and put a point right there. If I want 7, 4, 5, 6, 7, up to 4. So again, over 7, up 4, both positive. First quadrant, I'm going to end up with both numbers positive. And so this one is 7, 4. And then I have 2, 11. So 1, 2, up 1 past the 10, 2, 11 will be right there. And so that's the basic idea for graphing points. All right, so now we want to graph our line. Note, anytime you have x and y, no exponents, then you're going to have a diagonal line. So I'm going to make a little t-chart. And while, it may be a little tedious, the reality is this always works. It may take a few more points than you'd like sometimes, but it always works. All right, so first, let's make x, say, a 2. So I have then 6 subtract 2y equals 6. Well, of course, if I got 6 on both sides, they go out. I'm left with y is going to be 0. And again, if it helps, you can always do this. 6 minus 2y. The 6 comes from 3 times 2 equals 6. And again, both of those would be gone, leaving me with negative 2y equals 0. And so y would be 0. Now, I can also, hey, that's what making the y 0. What if I make the x 0? All right, so then that leaves me with negative 2y equals 6, which means then that y equals negative 3. And so I have a second point. Now, in reality, that's all I need for a straight line is 2 points. But practically speaking, I should always do 3 or 4 points just because if I make a mistake, I can catch it if the 3 or 4 points don't line up. If I only do 2 points, they always line up. So I can't ever see that I've made a mistake in that case. All right. So let's do at 0 and 2, let's do a 4. Okay, so x is 4, so that would give me 12 minus 2y. And again, the 12 was from 3 times 4. The x is 4 equals 6. Subtract 12 from both sides gives me negative 2y equals negative 6. Therefore, I'm going to get a 3. And one more. Let's make the x negative 2. And so negative 2 times 3 will give me negative 6. Subtract 2y equals 6. So add the 6 to both sides. Negative 2y equals 12. So then divide by negative 2. I'm going to get a negative 6. Now I can put my points in. Let's see, 2, 0. So that's 2, 0. And then I've got 0, negative 3. So there's 0, negative 3 there. And 4, 3. 4, 3. And negative 2, negative 6. Negative 2, negative 6. And you should see these are lining up. And so there is my graph of 3x minus 2y equals 6. All right, let's look at some more examples. Let's zoom out just so we can see everything more easily. Okay, 4, negative 6. So 1, 2, 3, 4, down, negative 6. So this one is 4, negative 6. Okay, negative 3, negative 9, negative 3, negative 9. There. And the last one, negative 3, negative 6, which ends up being right there. And 1, 2, 3, because we went negative x, always x first. And then 1, 2, 3, 4, 5, 6. Note that when the first number is the same, they're going to end up being one above or below the other. If the second number is the same, they end up being horizontally connected. All right, the other line we're going to do 3x plus 4y equals 8. So let's make a little t-chart again. If we make x 0, at part 0, we have 4y equals 8. So y will be 2. If we make x 4, so that's 12. So we're going to have 12 plus 4y equals 8, which will give me 4y equals negative 4. So that means y is going to end up being negative 1. If I make, say, a negative 4, then I'm going to end up with negative 12 plus 4y equals 8, which will lead to 4y equals 20 when I add 12 to both sides, which means then I'm going to have a 5. And let's do one last one, 8. So that's going to give me 24 plus 4y equals 8, which subtract the 24, it's going to give me 4y equals negative 16. So y is negative 4. Now you might say, well, why did you pick 0, 4, negative 4, and 8? Well, note that I always ended up with 4y equals some number. As long as that number is divisible by 4, I'll end up with whole numbers. So, I would do the same thing if these had all been 3s, then I would want to make these numbers end up being multiples of 3. Now we can go ahead and put our points on 0, 2. So note, x is 0, so I don't go left or right, I just go straight up 2. 4, negative 1. Negative 4 is 5. 8 is negative 4. Again, you can see that those are going to line up. Arrows just mean it can go on forever. And that, of course, is our 3x plus 4y. You can also notice a little pattern, by the way. Anytime it's set in this particular form and I have a plus y term, it's going to angle down. And anytime I have a subtract y like this, it's going to angle up. All right. Now let's go ahead and do a quadratic. So I'm going to make a little t-chart right here. So let's go ahead and do, let's say, we can start off with 0. So that becomes 0 and 0 and 1. And then we can go to 1. So that'll be 1, subtract 4, plus 1. So that will be a negative 2. We can go to 2. And let's see, that's 2 squared, that's 4, subtract 8, 4 times 2, so that's minus 4 plus 1, that's negative 3, then I can go to 3, so let's see, 3 is 9, 9 minus 12, yes, 9 minus 12 is minus 3 plus 1, negative 2, 4, and let's see, we have 4 squared, 16, minus 16, oh, feed back to 1. And there's that symmetry that I talked about earlier. Note, this point here, we will call the vertex, but negative 2, 1, 1. If I do another one, let's say we go to 5 now. All right, so let's see. 5 is 25 minus 20. That's 5. 5 plus 1, well, that'll be a 6. But that means that negative 1 will also be a 6. Now let's check. Negative 1 squared is 1. 4 times the negative 1 is negative 4. That makes it positive 4. So 1 plus 4 plus 1 is also a 6. So in fact, we did get all our values there. So let's see, 0, 1. 1, negative 2. Let's see, 1, negative 2. 2, negative 3. 3, negative 2. 4, back to 1. 5 is a 6. Negative 1 is a 6. If I did negative 2 here, I'll add 1 more. So negative 2, let's see, negative 2 would be 4. And then negative 2 times 4 is, that's going to be a positive 8. So 4 and 8 and 1, that will give me 13. So the negative 2 up here to 13. But then I can go straight across. No, I just went over 1 up to 13. So over 1 up to 13. And there's the rest of my figure. So basically, it's going to go this. And of course, it could keep going upwards as much as I wanted to. And so I have graphed a parabola. Now, whereas for a straight line, I always recommend, say 3 or 4 points. I would say a minimum of 5 points for a parabola. If you have the vertex already included, we will find out later on how to get to the vertex right away, but you can see the symmetry in the y values straight across, straight across, straight across. Here and here, here and here, and so forth. And so all quadratics will have that kind of shape to it. All right, next we have an absolute value. Let's take a look at what that one looks like. Alrighty, let's see. I don't want to get too big here, but I'm going to start with negative 9. So negative 9 plus 6 is negative 3. The absolute value makes it positive 3. The negative sign out front makes that back to negative 3. Negative 3, subtract 5, negative 8. And then we're just going to proceed. Negative 8. So negative 8 plus 6 is negative 2. Absolute value makes it positive 2. Negative sign makes it back to negative 2. Negative 2, subtract 5. We got 7. Okay, negative 7. So that gives me negative 1 in there. Absolute value makes it positive 1. That makes it back to negative 1, negative 1, negative 5. And we have a negative 6. Okay, now let's do a negative 6. So negative 6 and 6 is 0. So this is just a negative 5. Now let's go to negative 4. Or excuse me, negative 5 is next. Negative 5. So negative 5 and 6 is 1. Absolute value of 1 is 1. Negative 1, negative 5, back to negative 6. Negative 4. Negative 4 and 6 is positive 2. Absolute value keeps it at positive 2. Negative sign makes it negative 2. Subtract 5. And note that we're repeating things kind of like we did with the quadratic. However, when we plot these ones out, here's what we're going to get. So let's raise it up a little bit so we can see where the values go. So negative 9, negative 8. So there's negative 10. So negative 9, negative 8. Negative 8, negative 7. Negative 7, negative 6. Negative 6, negative 5. Negative 5, negative 6. Negative 4, negative 7. Negative 3, negative 8. Well, we do have symmetry, but instead of being a U, this is more like a V. Now, this one tends to be upside down because of that negative sign that was in front of the absolute value. So, quadratics, square terms, give us parabolas, U-shaped figures. And again, it opens up if it's positive x squared term. It would open down if it had a negative sign in front. Absolute values give us V-shaped forms. And again, this one was going down because we had that negative sign in front. All right. Now, what if we have a square root? Okay, let's go ahead and make a t-chart. My square root function here. Now, I'm going to start at negative 12 because I know that negative 12 and 12 gives me 0, and so all that's left is the 10. Now I want squares, so next I'm going to pick negative 11 because negative 11 and 12 is 1, square root of 1 is 1, 1 and 10 is 11. Then, let's see, 0, 1, 4, I want a 4, so I'm going to pick negative 8. That gives me negative 8 and 12 is 4, square root of 4 is 2, 2 and 10 is 12. Now I want a 9, so negative 3 and 12 is 9, square root of 9 is 3, 3 and 10 is 13. And let's see, next I want a 16, so I need a 4. 4 and 12 is 16, square root of 16 is 4, 4 and 10 is 14. If you do this kind of approach, notice that this is how they went. These go in order. 10, 11, 12, 13, 14. Started at 10, but then added 1, added 2, added 3, added 4, because I looked for the squares that give me 1, 2, 3, and 4. So this graph will start off at negative 10, or negative 12, 10. Negative 12, 10. Negative 11, 11. Negative 8, 12. Negative 3, 13. 4 is 14. Say 4 is 14. And if I had done one more, let's see, 25, so that means 13, which would have given me 15. 13 and 12 is 25, square root of 25 is 5, so 13 would have been up here at 15. And so there's the graph for the square root. Note, I didn't go to the left of this first point because if I had done any number bigger than negative 12, I would have had a square root of a negative number, which we cannot graph in a real number sense. All right, now we're going to do this one last. This is a cube function, just so you get a feel for the way a cube function looks compared to all these other functions. Now, the trick here is since it's cubed, cubes grow really fast. So for instance, 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64. You know, by the time I'm at 27 and 64, I'm totally off my graph. So what I'd like to do is keep it so it's only going, say, 1, 2, and 3 kind of things. Otherwise, it's just too big. So how do I get a 0 in here? Well, if I pick a 5, I'm going to put it right here. So if I pick a 5, 5 minus 5 is 0, and so all that's left is the negative 2. Okay, now let's get a 1. Well, if I pick 6 minus 5, that's 1. 1 cubed is 1. 1 minus 2, so a 6 gave me a negative 1. Likewise, if I did a 4, 4 minus 5 would be negative 1. Negative 1 cubed is still negative 1 because it's negative 1 times negative 1 times negative 1. Minus 2, that's a negative 3. And now we'll go to 2. So 7 minus 5, that's 2. 2 cubed is 8. 8 minus 2, that gives me a 6. And likewise, on this side, we're going to do a 3. 3 minus 5, that's negative 2. Negative 2 cubed is negative 8. Negative 8, subtract 2 more, is negative 10. And generally, just 5 points, of which the middle 3, notice how we went 4, 5, 6, 3, 2, 1, will have that kind of effect to it. So, graphing these, 3, negative 10. So, 1, 2, 3, that would be down here. And then 4, negative 3, 4, negative 3, and then 5, negative 2, and then 6, negative 1, and then 7, 6. So basically, this one is going to go like that. It's going to have a kind of S shape to it. And I only went through 0, 1, and 2. If I had gone to 3, like I said, 3 cubed is 27, and so I would have been far off the chart. So this is the square root one. This is a cube. All right, we have 2 points. We want to finish off with the distance formula and the midpoint formula. So first, distance formula. You will not have to have any formulas memorized for any quiz or test. Don't forget to square. So in this case, and again, this is like x1, y1, x2, y2. So x2, negative 1, negative 1, subtract a negative 3. Gotta make sure and keep your signs straight. And then we have y2, the 6, subtract the negative 8. My little brackets here are just for me to keep straight what I'm plugging into the formula. Okay, so 1 subtract a negative 3 becomes 1 plus a 3, which is 2. And here we have 6 subtract a negative 8, so that's going to become 6 plus 8, which is 14. Putting those two together is going to give me 200. And so D equals 10 root 2. 200 is 100 times 2. I can take the square root of 100 to get the 10. The 2 I cannot. All right, now midpoint. Midpoint formula. Remember, it's basically the average of the x's, the average of the y's, x1 and x2 over 2, y1 and y2 over 2. So what are we going to have here? All right, x1, negative 3 plus a negative 1 over 2, and let's see, negative 8 plus a 6 over 2, which will give me, let's see, that's negative 4 over 2, so that's negative 2. And that's negative 2 over 2, so that's negative 1. So the point that's halfway between those will be negative 2, negative 1. And so, chapter 1, or excuse me, section 1 of chapter 2.